Hello, welcome to Dakota Prep's tutorial on sizing motor branch circuit conductors. So we have this question over here that says, what are the minimum size copper THWN insulated conductors permitted for a 25 horsepower, 460 volt, three-phase design B squirrel cage motor that has 29 amp rating marked on the motor nameplate? Okay, so the good news is for sizing motor conductors, it's really easy. It's really straightforward. If we look at section 430, let's try this again. 430.22, it tells us that our conductor ampacity shall not be less than, has to be at least as big as, or the same ampacity here larger, as the full load current of the motor times 125%. Right, 125% of the full load current rating. Now, there's a little bit of a catch here, right? Our full load current is not the nameplate current, okay? It's not that. It's not this number, okay? It's the table value. You guys have to remember back to 430.6A1 says, hey, if we're sizing conductors, short circuit protection, or our switch or disconnect size, then we have to use the table value found in 430.247, 248, 249, or 250, not the nameplate current rating, right? We only use the nameplate current rating for overloads, for overload protection, right? Or heaters. So, okay. So, like I said, we'll just get rid of this. Our conductor ampacity has to be as big or bigger than, greater than or equal to, full load current times 125%, or 1.25. Well, that's a point there. It's an obvious point. So let's go look at our table value. So in this case, since it's a three-phase motor, we need to look at table 430.250. So it says, hey, we've got us a 460 volt, 25 horse, three-phase motor. So 460 volt, 25 horse. That's going to give us a full load current of 34 amps. You guys notice our nameplate current was only 29 amps, but that's not what we use for this. We use our full load current. So let's get rid of this. Now we know our full load current is 34 amps. So 34 times 1.25 gives us a grand total of 42.5 amps. So our conductor ampacity has to be greater than or equal to 42.5 amps. So we need some THWN insulated copper conductors that have an ampacity larger than 42.5. So okay, pretty straightforward. Let's move this out of the way and get our table out here. Our favorite table, everybody's favorite table, table 31016. Okay, so THWN is found in the 75-degree column. We need some conductors that have an ampacity larger than 42.5. So what's that going to be? Bingo, there we go. Number 10 is only 35. That's not going to get it done. Next higher size, number 8s are good for 50 amps. Well, 50 amps is definitely larger than 42.5, which means that number 8s will be just fine for this application. Well, since we need number 8s, that's going to be our green light, our green ink anyway. Correct answer, our second option here. Now, something I want to point out just real quick that messes with a lot of electricians. Number 8, so this is going to be much smaller than the ampacity wise than our short circuit protection, than the breaker size, right? Now the reason for that breaker or your fuses for a motor are for short circuit protection only. Okay, it's only for short circuit protection. That's not what's protecting the motor or the conductors. What's protecting the motor or conductors are the overloads, those heaters, or whatever that you have or you're using for overload protection. Okay, so that's why your motor conductor sizes are always so much less than the breaker or fuses that are out front, because that breaker and fuse, it's just there for short circuit protection. It's not actually protecting the conductors. The overloads are. So our correct answer, number 8. Number 8 will be just fine for this 25 horsepower motor.